All right, we're going to be looking at being able to simplify expressions using exponent rules. And so this is just a quick review of things we've already learned. These ones are going to focus, or this video will focus a little bit more on negative exponents, and as well as incorporating a multiple exponent rules into any one problem. So if we look at first here, we are multiplying two expressions together. I check to make sure that there's not an exponent here or here that I'm going to have to do first, and there's not. So therefore, I am just going to start by multiplying what would be the coefficient of 1 here times 3 to get 3. If I look at my x's then, next I have x to the 4th and x to the 4th. And that's where I add the exponents to have x to the 8th. Remember, if you need to visualize that, you can visualize 4 exponents here and 4 here, and that would give us 8 altogether. Now, I can do the same thing when I look at my y value, my y bases here, y to the negative 2 and y to the 5th. I can still add those exponents, and that's going to give me y to the 3rd. And then my last one here, I have z to the 3rd and z to the 3rd, which will give me z to the 6th. And once again, one of the things we always ask ourselves is, how do we know when we're done? Is that we have a coefficient here of 3, and then we have what we call unique bases, meaning that we just have one x left in the problem to the 8th power, we have a y to the 3rd, and we have a z to the 6th. And so that tells us that we have simplified as far as we can go. All right. If we look at the next problem here, there's several different ways to approach this problem. So if you work the problem out on your own, you get a different answer. If you get the same answer by a different method, that is perfectly fine as long as you're applying those exponent rules correctly. I'm going to show you one way to approach the problem, okay? So the first thing I'm going to do is just this regular old division problem. Okay, remember that coefficients do not have any special rules. We were using the same rules we always have for integers. Negative 20 divided by 4 is going to be a negative 5, or negative 5 over 1. Okay? Now, if we look at our x's here, I notice that this x here is x to the negative 2. So I'm going to take that x to the negative 2 and I'm going to drop it down to the denominator. But there's already an x to the 2nd there in the denominator. And so what would happen is that if I have x to the 2nd that was already there, and I've brought down that additional x to the 2nd, I now have x to the 4th. And so if you want to write that out in multiple steps, you can. If I look at my y values, I have y to the 3rd and y to the negative 3. So I have this y to the 3rd that's already here, but this y to the negative 3 is going to have to go up to the numerator and become a y to the positive 3. And if I have 3 y's here and 3 y's there, that is going to give me y to the 6th. And then the last thing I'm looking at is z to the negative 1 over z to the negative 1. Now, if you notice, we have the exact same thing in the numerator as we do in the denominator. And whenever that happens, what that tells us is that they cancel out. I mean, think back to if you have 8 over 8, those cancel out and our answer is 1. Now, if you forgot about that, you don't think about that, what would happen is that if we look at those z's and we say, well, here's z to the negative 1, I'm going to move it down to the bottom, make it z to the positive 1, and here's z to the negative 1. I'm going to move it up to the top and make it z to the positive 1. Well, then what happens is now we can see we have the same thing in the numerator and in the denominator, which would create, when we take that 1 minus 1, which would create a z to the 0 power. And we know that anything to the 0 power is 1. And so that drops out of the problem. And so here we have our final answer simplified. Okay, I'm going to take a look at the next one here. If we look at this, this is actually a problem that has a few parts to it. So I'm going to take and I'm going to look at the denominator first. Why would I look at the denominator first? Well, what I see here is that I need to multiply these two things. So before I can work from numerator to denominator, I've got to do some simplification here, almost as if it were a separate problem. So I'm going to leave this x to the negative 1, y the negative 2, exactly how it is. And I'm going to take it, I'm going to multiply in the denominator here. So I'm going to take the 4 times the 2 to get an 8. And then I'm going to take x to the 4th and x to the 2nd to make that x to the 6th. And then I'm going to see that this y, the negative 2, doesn't match up with anything, but I'm going to have to bring that y to the negative 2 over here. So I've done that first step in which I've multiplied, and now I'm going to take and work from numerator to denominator. Well, the coefficient here is a 1, and so as I work towards my answer, that's what's going to stay in my answer, is that 1/8. Now, we know that we don't need to have that 1 in front of there. It's implied to be there, but if it helps you to keep it there as a placeholder, then go ahead and do that. Okay? Now, if I look at my x's, I already have in the denominator x to the 6th. And if I take this x to the negative 1 and I drop it down to the denominator to make it positive, I have the 6 that were there, and I brought 1 more in, and now what happens is that I have x to the 7th power. Now, what you may notice is look how we have when we go to do our y's. Y the negative 2 in the numerator and y to the negative 2 in the denominator, exactly the same thing. Those are going to cancel out. And that leaves us with our final answer simplified. All right, if we take a look at our last one here, we're going to look at, second to last one, excuse me. If we look at this, I see that I'm going to leave this x to the 5th, how it is, because I need to, in this denominator here, I need to take everything and raise it to the 2nd power. And one thing I've got to be careful about is that my coefficient there is a negative 1. So what this actually means is I have negative 1 to the 2nd power, and then x to the 5th to the 2nd power, and then y to the 3rd to the 2nd power. And so negative 1 squared is a positive 1. Power to a power, I multiply to get x to the 10th. Power to a power, I multiply to get y to the 6th. And so now this is going to go into my denominator here. And I'm going to have x to the 5th divided by x to the 10th, y to the 6th. Now, I really know that both of these coefficients here are 1, but 1 divided by 1 is just a 1, so I don't need to worry about that. Now, what I do see is that I have x to the 5th here and x to the 10th here. So there would be 5 x's in the numerator, 10 x's in the denominator. That is going to leave me with just 5 x's in the denominator. I also notice that this y the 6th is in the denominator. It's a positive exponent, and there's not a y value up here in the numerator for us to be able to pair it up with. And so now everything other than a 1 has been removed from the numerator, and our variables x to the 5th, y to the 6th are in the denominator, and there's our expression simplified. All right, here's our last problem. Once again, there's many ways to approach this problem. I'm going to show you one. I would take and I would hold off on that exponent to the 2nd power. The reason why I would do that is that I see that there are things inside this parenthesis that I could simplify that are going to make it a little easier for me. For example, I can look at the coefficients and take 10 and divide it by 5 and get 2. I could also take x to the 2nd over x to the 5th. If I have 2 x's in the numerator and 5 in the denominator, that means I would have x to the 3rd left in the denominator. If I look at the y's, I have y to the 5th in the numerator and y to the 2nd in the denominator, and that's going to leave me with y to the 3rd in the numerator. So the first thing I'm going to do is I'm going to work inside those parentheses and simplify. Now I need to take everything inside the parenthesis and square it. So what would happen is that I would have a 2 to the 2nd power, a y to the 3rd to the 2nd power, and then an x to the 3rd to the 2nd power. And so when I go to write my final answer here, the 2 squared, 2 times 2, 4. Power to a power, 3 times 2 gives us y to the 6th. Power to a power, 3 times 2 gives us x to the 6th. And that is our expression simplified.